I know it's just something.
Like once I start it, I'm sure I'll be able to like.
Overly emotional. Introspective. Trying to figure out some of the challenge going to be punch. But he's excited. No, but I think yeah, that's like I can't grasp what's I think like there's quite a few parts where I school is really like I don't want to I think that's what makes it I'm never telling you more often than something you might not it's like a best game. That's always been great. I just no, can probably do it. That's exact same. Yeah. It's not that bad. Just turn on the it's a freaking core. Actually, no matter what your circulation.
All right, let's begin, everybody. So we're downgrading the midterm. The midterm is all graded. It's sitting somewhere in a box, and it's been scanned as well. But it's not going to come back to you until later today. So tech staff has to. There's a person who has to actually come here physically and upload your midterms to a web server, and they're only able to do this later in the day. So you'll be able to download them from a web page. So you should check Piazza, and we'll make a post about it. So what we'll do today is actually review the answer key that is posted on Piazza. So you should make sure to grab it from there. And we'll also cover 2 design principles. We'll kind of head off into yet another direction for the course. We're going to be talking about design and how to structure a code properly. So a very interesting and kind of subjective topic. So today we'll cover coupling and coherence. And then just a kind of strong reminder that you should be working on Waldo. So this is week 1 out of 3 is gone. So you have 60% time left, essentially. So don't leave it to then. I mean, it's very hard. Okay, you're going to run into a bunch of problems. And we're not going to have the cycles to help you if it's at the very end. And then the final thing is there's a lecture lab that's posted online for coupling and cohesion. So you should go ahead and solve that over the weekend. Just work on it on your own, because we're not going to get to it on Wednesday since we're losing Mondays. Okay, so let's jump into the midterm. So the very first question, this is not it. Her first question had to do with the following code that you were given. And in the code you have 3 classes, A, B, and C. And you were told that your execution is going to start at the main method defined in class A. and then you were asked what would actually happen, right? Like which lines get executed, what exception is thrown, and so forth. So what we realized is that for one of the methods, fun2, it may throw an E1 exception, but it's not clear whether it does or not. Okay, so this do something could throw an E1 exception, or it could not. So that was an issue, because that actually changes the validity of some of these questions. Okay, so this first question, you got 2 points on it, whether you answered true or false. So either answer for the first one, the 6th question, or the 11th question. Okay, is correct. So everybody starts with 6 points. Perfect, right? All right, good. That's the good news. So starting from there, let's go on to actually figure out what happens, right? So initially, you're just given this code. You start off in main. You then create a new instance of b, and you call b.fun1. So fun1 takes you to this function defined in class b, where the first line is create a new c, and then enter the try block, and call c.fun3. Fun3 in class c is defined below, and what fun3 does is it throws an E1 exception. Okay, so at this point, you're looking for a handler to E1. There's no handler to E1 within fun3. You come back to fun1, and you say, is there a handler for E1 in this method? There is. There's a catch. So this exception is caught, and you execute whatever's in the catch clause. So this is fun4. Fun4 takes you down below, and fun4 throws a new exception, E2. You look for the catch. There's no catch within fun4. You come back to the catch block within fun1. There's no catch for E2 here. That means your pending exception at this point is E2. So we handled E1 with this catch block. We haven't handled E2. So you're going to go back to main. But first of all, you need to execute finally. Right? So before I come back to main, I execute my fun2. My fun2 does something. And then I go back to main. Main doesn't have a catch block around fun1. That means my program terminates. So what that means is that my line 5 executed or not. It did not, because I never reached it, right? Because execution stopped at line 4. Line 16 is here, and it did execute. It executed when we caught E1. And then line 23 is this do something, executed exactly once, because we called it within the finally clause. Okay, so I didn't reach the second fun2 call, so that means I executed exactly once. So that's part 1. And then we have part 2. Part 2 says change class C. So you could do this in a couple of ways. Easiest way is to actually just change it on here. So change this to be E1, E1. Change the code above to be E2, E2. So now we have a slightly different exceptions that we may throw. We have to go through the whole thing and try it out again. If you have Eclipse, you can try to type all of this in and actually run it. And you could get your answer that way. Completely fine. I hope some of you did that. Okay, you start off in main, create a new B, call b.fun1. Fun1 gets here, create a new C, enter the try block, call fun3. This is a modified fun3. It does something else now. It throws a new E2. So now you're looking for a catch to E2. There's none here. Come out here, there's none here. So you don't execute this catch. You want to come back to main, but first you have to execute the finally. So I execute a fun3, then I execute fun2. I do something. I come back here, there's no catch for E2 that was thrown, and I terminate. Okay, so looking at the questions again, line 16 is the catch body. It's a catch for E1. E1 never happened, so it never executed. Line 23 is the do something. It did happen because I executed the finally clause. It did not happen twice because I never reached the second statement. right? And it executed exactly once. And then finally, part 3. Whoa, that looks kind of ugly. Weird. So this question says, now that you have made this change to class C, right, consider now that you've actually made E2 extend E1. So that means that instead of extending exception, it extends E1. Right, so my type hierarchy now is exception. Can't really see that. An exception. This thing is going to be subclassed by E1. And then this thing is going to be subclassed by E2. Okay, that's my type hierarchy now for exceptions. So we run the whole thing. Create a new B, execute fun1, enter fun1, create a new C, call fun3. Fun3 behaves as before, it throws an E2 exception. But now remember, E2 is a subclass of E1. So if you have a catch block like here that catches E1, it automatically catches any subclasses, all of the subtype exceptions. So it's going to catch E2. So I throw E2 here, I come back here, and I execute the catch block. So that calls fun4. Fun4 throws an E1. And E1 thrown here has no try catch, right? There's no catch inside the catch block. So there's a pending exception, E1. So now at this point I want to exit, but before I exit, I want to call and execute whatever's in the finally clause. Execute fun2, come back here, and then I terminate. So very similar trace, except that now I actually did execute the catch block. So subclassing E1 made me handle it in this case. So again, line 16 is executed because the catch block executes. 23 is executed once as before because of the finally. And it's not executed twice, and it's not executed never. Yeah?
What happens if you consider that do something to throw E1?
Yeah, if do something throws an exception, then in the finally clause, that exception overrides whatever's pending. So if E2 was pending, now it's E1. Okay? But whatever it throws, after fun2, if there's an exception, it'll go back here and it'll terminate. So it doesn't change the validity of any of the other answers. Right? So regardless of whether it throws an E1, it could even throw an E2, you'll still never reach this line 5 because there's no handler for this E1 within the finally, and there's no handler for it within main.
Oh, I see. So it doesn't go back to the method. So it wouldn't be caught in the class B. It would only be in the finally.
If there's an exception in the finally block, then you're looking for a catch within the finally
Oh,
block.
I see. Okay.
And since there's no exception, no catch block here, that means you exit back to main, and there's no catch in main either. Right. So, I mean, this was our mistake, which is why we're giving you extra points. We designed it thinking that it wouldn't throw E1, but of course, you know, by saying that it can potentially throw E1, you have to reason through that case as well. More questions?
You have a catch block in fun2, like just throw in that catches E1, or is it still gonna?
Well, it depends on what fun2 looks like, right? My fun2 could look like, you know, throw new E1, and then I could have a try catch E1.
But I mean, like, could you potentially catch the E1 that was thrown in? Like if you, because you go to fun4 and you throw an exception,
Right.
and then you go to your finally clause, could you catch your? No.
No, that's not a corresponding catch, right? So it has to be a catch along kind of a normal execution flow. Once you enter the finally, that's kind of a different stack. So there's a pending exception, and you can override it, but you can no longer handle it. Okay? Because finally executes as if there is no exception, right? So you're executing sequential code. So you're not going to hit any of the catch blocks because they're intended for any exceptions that might arise during the filing, not any outstanding exceptions. Right? Any of those catch blocks should be outside of the filing. Right? Other questions? Okay, that's question 1. Let's go on to question 2. By far, your favorite question. Question number 2. Question 2 had to deal with the UML diagram, but in a fun way. We didn't have you draw the diagram. We didn't have you extract it, which is what you were practicing. Instead, we had you come up with code for the UML diagram, right? Which is kind of the inverse exercise. So the idea is, now you have a UML diagram. Somebody gave you the specification. Write down the code for it, right? This is a very common task. In fact, it's more common than extraction. So given this diagram, you're supposed to write code to capture the relationships between recipe, kitchen, and appliance, and capture all of the associations and aggregations in this diagram. So here's the code for recipe. And what we're looking for is that, first of all, you must have the right cardinality on your elements, right? So first of all, you have to define a list of appliances, produce, and spices. And it didn't need to be a list. It could have been a collection, could have been a set, could have been an array. We didn't care. Could have been a map, right? All we cared about is that your recipe knows about multiple spices. Your recipe knows about multiple produce. Yeah, Lucas?
I thought when I was reading the question, it said use list.
Yeah, we did say use list, but we were forgiving. We were using list mostly for our sanity. Yeah. So if you didn't use list, you didn't lose any points on it, because that's not what we cared about. So recipe knows about multiple appliances, right? So you could make that a list. It knows about multiple produce, multiple spices. And it must know about a kitchen. This is a bidirectional association. So just define these fields, right? We said just write fields and constructors, nothing else. Yeah?
Would we lose marks if we added the other fields?
No, we didn't care if you added more stuff. That just made your life more difficult, right? So we only cared about these relationships. If you decided to spend your time writing other things, that's fine. Yeah?
So in the UML diagram, the appliance is 0 to 3.
Yeah.
Is it okay from the constructor we specify or we initialize the array for appliance? We make it 3.
Oh, you mean when you initialize the set of appliances, you gave it the argument 3 for the number of appliances? Yeah, that's fine, as long as you could maintain 3. I think some people created one appliance and then assigned it to 3 different things, which doesn't work, right? It's one reference. Yeah.
How would you specify it to be a maximum of 3?
Maximum of 3, you can actually set the size of the list, of the initial list that you create, or the array. You don't have to. So you here, this here, for example, this produce is just a list of produce.
Yeah, so
We don't bound it.
It can be.
And you could do the same for appliances, right? So not necessary. Yeah.
So what if you had 3 different fields for each different appliance instead of having a list?
I think that was fine. Yeah. You could have 3 fields as 3 separate appliances instead of a list. Yeah. It's the same relationship. Yeah.
What was exactly meant by the aggregation from kitchen to appliance? Because there's no number of kitchens and there's no arrow.
What did I mean by the relationship? What?
Like,
This relationship?
Bidirectional, kitchen should have numbers. But no.
So this number is always assumed to be 1, right? You could write it to be 1 or you could omit it. But this is bidirectional, so an appliance knows about a single kitchen. The reason it's always 1 is because it's a whole parts relationship, right? So it's part of one single whole. So yeah, if you had extra code and you implemented the other methods, we just kind of ignored those. We only concentrated on the relationships and that you got those right. Okay, so an appliance does all of those things. And then, of course, we gave you a hint. We said kitchen needs to know about recipe. So just use the add recipe method in kitchen. So we're looking for something that looked like this. k.add recipe, this, meaning add my own reference. But you could have also created a new kitchen object, right? That's completely fine as well. We didn't say which kitchen you had to know about. All right, what about the kitchen? Kitchen needs to know about multiple recipes, needs to know about multiple appliances. So you have 2 lists, 2 sets, 2 collections. And then we said that it must know about 1 or more appliances, and that 1 appliance must be a refrigerator. So you either take a refrigerator as an argument in your constructor, or you just create the refrigerator. Your choice. Either answer is fine. And then for appliance needs to know about a kitchen, right? So exactly 1 field. Kitchen K, you could initialize it, you could create a new kitchen, whatever. So the key thing is that we did not want you to express relationships that were not in the diagram. So for example, here there's a unidirectional relationship between meal and recipe. If the recipe knew about a meal, you lost points, right? Because you basically implemented the wrong relationship. Or if your spice knew about recipe. You didn't have to add spice, but if you did and it knew about recipe, that's a problem. Other questions on this one? Renee?
If you didn't add things to the list inside the constructor and you made add methods to the site, would those count or?
If you did not add things,
Add recipe, you made add recipe on the site, but you didn't add anything inside the constructor. And you just initialized the thing.
so for some of them it does matter. So here, for example, I must add a refrigerator to my kitchen. At the end of the constructor, my kitchen knows about a refrigerator. If you have a method, add refrigerator, it doesn't work, right? Because at the end of the constructor, this would be a 0. 0 dot dot dot. Right? Yeah.
You said that you can't have a meal in recipe,
Yes, you cannot have a meal in recipe.
but there's a 1 there right below meal connecting.
Yeah, but it's unidirectional, right? So this is an arrow, which means that the meal knows about a recipe, but the recipe doesn't know about the meal.
I thought that the arrow was optional and that you could have the arrow or not have the arrow.
No, the arrow is everything. So this is unidirectional, right? And this is bidirectional. The numbers are optional. So the numbers are optional, especially in aggregation. They're not optional anywhere else. So these aggregations do not have numbers, so this would be a 1, this would be a 1, this would be a 1, this would be a 1. Yeah, Jane, me too. Why does the kitchen class need refrigerator? We gave you a comment that says every kitchen must have a refrigerator. And the kitchen knows about at least 1 appliance. So your code needs to choose some appliance. Right? And our comment told you what that appliance needs to be. So you have to follow this comment. Okay. That's number 2. Question 3. Question 3 seems to have been one of the more difficult questions for you. By the way, we don't know what the tallies are and stuff. We haven't actually scanned the marks in, so we don't know the distribution. But once we have it, we'll post it on Piazza. So for this question, the point of this exercise is to think about an invariant for a class, and then make sure that the class satisfies the invariant. But the point here is not that you just want to make it satisfy the invariant right now at this point. The reason you're adding invariants is so that you protect yourself from future modifications. So if later on I change my class, how do I know that it's still correct? Right? If later on I add fields or I add new methods, how do I know that the stuff that I have right now still works? That's kind of the reason why you add invariants in the first place. So you want invariants because invariants tell me about what are correct states for my class. And the only way I can really satisfy those is if I check them. And so I need to check invariants at specific points in my code. And those points are usually at the end of the constructor and beginning and end of all of the public methods. Yeah.
In the lecture reading, it said it was sufficient to check it at the end of methods.
Yeah, so this was going on. There's a comment on Piazza about this as well on page 15. So that chapter gives you examples where invariants are checked at the beginning and end, and also states explicitly that they have to be checked at the beginning and end. And then at the very end, it says generally we don't check them at the beginning, right? So ambiguous. We're trying to figure out what to do about it. Yeah.
You put the invariant in 4 times. Does that mean you couldn't have done any more than 4 times?
I've done it 5 times. You can't actually see it. Sorry, here it is. Right, so it's at the beginning of gain altitude and the finally of gain altitude, at the end of the constructor, and around the adjust landing gear. So all of the public methods, and there are 2, gain altitude and adjust landing gear. And then at the very end of the constructor, because when you build the object, how do you know that it's in the right state? Right? So after you've built it, you need to check it. So we did not take off too many points if you had a few extra ones. But if you put them everywhere, we took points off. Right? Obviously, the trivial solution here is insert the statement after every line of code. Right? But obviously, that's not a great solution. You don't want to be checking your invariants at that granularity. Furthermore, you should know that within my body of my method, I can violate my invariant. It's completely reasonable for me to violate my invariant somewhere in the middle. What needs to be true is that by the time I finish the method, I complete it, my invariant is back to being true. Yeah.
For the invariant at the beginning of the adjust landing gear, wouldn't that essentially make it, wouldn't it stop the method from working? Because adjusting landing gear is meant to be when you go above whatever height, it pulls up the landing gear. But if you have the invariant first, while you do that, your height's going to be higher than 500 and your landing gear will be down. Otherwise, if you have that invariant there, you're never going to be able to move the landing gear.
Yeah, it depends on how my code is used. So I didn't give you ways of actually running this code, right? And also, this doesn't mean that this code is correct, right? But that's a very good point. Yeah, absolutely. If I actually created a test for my code, then maybe this code doesn't satisfy my invariant. Right? The point is we want to add these checks so that we know that that happens. And how would you fix this, do you think? So I think the way to fix this is to make this private. Right? This call is really a helper method that's used within the class. So it shouldn't be exposed to anyone outside of the class.
So are you going to be taking off marks if people didn't put the check invariant at the beginning? Because I kind of thought that if you're checking the invariant at the end of each method and you check it at the end of the constructor, then isn't it it's unnecessary to check it at the beginning?
Yeah, so we took off points if you didn't have them exactly in these locations. Okay? But then since a lot of people complained about the reading, the fact that the reading stated that in general you can omit these, we're trying to figure out maybe how to adjust the example. Yeah.
For the second invariant, we can put after try, can we?
Put it after try. I think we allowed you to put it after try. You really shouldn't, but I think we let that slide. Yeah.
We should do it before any code.
It should be the first statement in your program. Yeah. Other questions? Okay. Let's look at the next one. Question 4. This was my favorite question. And you seem to do really well on this one, which is great. So this was the quiz builder question. And so the code should have been familiar to you, right? This was from assignments. So if you did the assignments, then adding a new quiz was kind of a no-brainer. You've already added new quizzes to that project. So your job was to add this really long name quiz to the project. Time-limited questions with freebies quiz. What were we looking for? So the first step is that you have to initialize this class. So we told you what the constructor took. And you had to maintain some state about the number of freebies remaining. So you needed to define some variable. You needed to make sure that it's initialized. And then you also had to initialize the constructor. You had to call your supers constructor. Right, so those 3 were important. So we're looking for those. For the body of this class, the best way of really well, really the only way of implementing this is to override submit answer. So if you've overridden other things in this class, we didn't care. You didn't need to, but you didn't lose points for it. If you defined other fields or redefined supers fields, not very legal, not supposed to do that, we didn't care. The key thing here was, does your submit answer work? So you could have typed this into Eclipse and actually run it, right? It was part of that project. And for actually implementing submit answers, we're looking for the fact that you are reusing functionality. So super.submitAnswer and super.gradeAnswer reset time are two calls that make this code very simple. Right, so I'm reusing all of the logic within my super class for creating this new quiz. So that was the key thing. Lucas?
I don't think you could actually use super.submitAnswer because it would print out a statement which wasn't accurate if you did.
Yeah, so we're not looking for the validity of the string that you return. So if you return empty string, you return the string that was generated by submit answer, we didn't care. What we cared about is the behavior that's defined in the bullet points for the class. Right? So this quiz must allow the user to violate the time per question exactly this number of times. Right? So if you wrote a quiz that did that, you got full marks. Right? Assuming that you reuse your super. Because if you copied code from your super, that's bad. Right? We don't copy code. So this is one solution. There were other solutions that were feasible without the try-catch. Right? So some people came up with those as well. Questions about this one? Let's get to the last one. Question 5. So question 5, again, reference code on the handout. And this code basically just defined a person. The person has some name and age, and it has a constructor and it has an equals method. That's it. And so you were asked to reason about what happens if you were to add a line of code here, right after people.add Jerry. So you could do this by, hey, you could type in this code in Eclipse and actually run it. You could do that. Because this equals is actually just auto-generated by Eclipse. And let's go through some of these. So my first question is people.contains new person Fred. Well, if you think about Jerry versus Fred, Fred is a new object, completely different object from Jerry. Nothing is equal about it. Right? So if I'm trying to see if my people contains new person Fred, then it's going to return false. Largely because it's a completely separate object. Second question, more tricky. I now create a new Jerry. My Jerry has the same exact data. Its name is Jerry and its age is 54. And the answer to this is false again because note that this thing has no hash code. It has no hash code. So that means when I'm looking up people.contains, I'm going to take the hash of this object, and the hash code of that object is just the memory where it's located. And the hash code of this object that I created here, well, it's a different memory location. So they're not going to match. So I won't be able to find the Jerry I put in. So that's false. Last statement, people.contains Jerry, well, now I'm just checking whether it contains exactly the Jerry I created. It's identical in every way. Hash code matches. Right? And my equals matches the name and age. So it's going to work. And then for part 2, you're supposed to change this code to add a hash code. So imagine I had a hash code here that just returned the age of my person. And I had the same set of questions. So for Fred, my hash code would return 54, and Jerry is also 54. But then my equality would come into play. And since I'm comparing names in my equals method, it's going to be false. I'm not going to, see that Fred is in there because Jerry is in there. Second question. Now I create a new Jerry. It has the same fields. Hash code matches. And since it has exactly the same fields, name and age, equality is going to be true. Right? So it's going to be true for the second question. And the final one, still true. If I have the same object, It has the same fields. It has the same hash code by definition. So it's going to be true as well. Questions about this one? This last question? Yeah. Actually, the guy behind you.
I read during the exam, I was looking at the Java API, and I'm guessing that I was confused by the hash set.contains method, because it said that it'll return true if and only if E is not null, O is not null, and the E dot equals O. So I'm guessing that the method description is live, because it needs a hash code to be the same.
Yeah, so your hash code has to match, right? This is the first step in evaluating whether your set contains an element. Yeah. Other questions? Yeah.
So the hash code is just to help locate the object, right?
Yeah, the hash code is an optimization to find the locate object. Yeah.
So in part one, there is no way to locate the Jerry with the same value, even though the value is the same. So there is no way we can actually reach it.
Yeah, the way to think about it, remember this diagram of kind of the array, right? So I have Jerry, and it says Jerry 1, and it's hashes to some value, right? And this is where it's located. And then I have Jerry 2, and it hashes to a different value. It's located in a different location in my array. So because they're in different locations, right, I don't know that, there's another Jerry in a different location that has the same value, right? So they really need to hash to the same cell in order for me to find one that matches. Yeah.
Just out of curiosity, when you have a data with different fields, how is it stored in the memory? Is it one location for the whole object with its fields, or is it one field to its own location per object?
Well, all data has a memory location, right? So every field here has a memory location. Furthermore, all code has a memory location. So this is something that's a little bit more advanced for 210, but each of these methods must be located somewhere in memory, right? So both code and data must reside in memory somewhere. Okay, and so when you call a method, you're actually just reading some location on memory, and you're executing it, as opposed to reading it and using the value for something. So every piece of data has a location. The allocation of this thing in memory, whether it's co-located or whether it's spread across, depends on the policy of the JVM, of the Java.
So each field has its own memory location.
That's right. What is it calling?
Yeah, is it using the equals or is it using hash set?
So contains is a method on people, right? It's a method inside of hash set and this hash set that I created. So when I'm calling contains on the object people, which is an instance of hash set. And internally what contains does is it takes a hash of whatever you pass in, like Jerry, and then checks if that hash code already exists. If it exists, then it checks whether there's equality between what it was passed and what is already in the hash set.
So we check the hash code first and then check.
That's right. No?
Will you guys maybe give us more realistic practice midterms next time, or practice final?
We'll try to give you more practices for sure. Yeah.
Not enough, but it's not.
Yeah, I guess my perspective on this is kind of even more stricter than Gail's, which is that we're giving you concepts, right? So the form in which the question takes could be anything. So we kind of want you to be surprised in the exam. I don't want you to do a bunch of questions and then regurgitate what you learned from that form on the exam. I want you to see a different question that you're able to answer because you understand the concepts. Right? That's what I'm attempting to do. But of course, we're going to give you questions in the approximately same form. They're going to require some Eclipse, and you're going to have to use existing know-how. You should be able to answer those. Right? But there'll be more we'll give you more help for the final, for sure. There's going to be review sessions, longer ones. Okay, let's get to some other topics. Very limited time. So we have 2 design principles to cover. So when you're writing code, you could write your code in many different ways. And you already know this, right? So for the exam, there are many possible answers for question number 4. And there are many ways to answer the questions on WebGap, right, for the assignments. So there's a lot of ways in which you can write code. So what is the right way to write code? You might be asking yourself. And so the answer to this is to follow some possible principles. So in software engineering, there's 2 principles that you will learn about. There's not very many that you can really rely on. So we'll talk about coupling and cohesion, but in general, software engineering is not like physics. It's not like chemistry or biology, where you have very well-defined, strict principles. So there's no thermodynamic laws that will tell you what can and cannot happen in a software system. Because software code can be written in so many different ways. It's very flexible. And so the principles that we give here, you can think of them as rules of thumb that people have learned about through experimentation. You can always violate them, but if you do so, your code is not going to be very robust. It's not going to be good design. Okay? So coupling and cohesion. So when we talk about cohesion, this is kind of a simpler one to tackle. Cohesion really talks about whether the elements in my module make sense together. Right? So does the functionality in a module make sense together? So a module contains multiple things. And we create modules and we create boundaries, modularity, so that we can do a bunch of good things. Like we can do information hiding. We could declare a field to be private so as not to expose it to the rest of the world. But when you create modules, you kind of have to say what goes into a module and what stays out of a module. Okay? So that question is kind of difficult. So what I have open here is figure drawer complete. And I have selection tool class opened up. So it's a class that represents a selection tool. The modularity boundary was defined by people who wrote this code. And they decided that a selection tool should be its own thing, right, within this project. So by deciding that selection tool is a thing, is a module, this automatically constrains what can be added to this class and what shouldn't be added. What should be and what shouldn't be. So for example, I might decide that a selection tool should, maybe it has some method that says public, Boolean is enabled. Right? I might have another function that does public void disable and public void enable. So I can add these methods here, and they all act on my selection tool, and they all make sense. Right? Because they have to do with the selection tool. Now, if instead I decided to add a different method, like public save file, and then Boolean as XML, this method makes no sense. What would it be doing inside of a selection tool? Why would I be saving a file from within the selection tool? So we say that a module has low cohesion if it contains methods that have very little to do with one another. Right? This is where the definition of a module becomes very fuzzy. So if it has save file and also create button and add listener, it has low cohesion. If I remove this thing, then all of a sudden it has higher cohesion because it makes more sense. Now this is purely a subjective concept, right? Because you have to reason about what sort of functionality is somehow cohesive with the other methods in my class. And that's purely a kind of a very design-oriented question. There's no right answer. There's no extremely wrong answer either. So that's what cohesion is about. Coupling Coupling talks about dependency. And really the best way to think about dependency is, does a module know about a different module? Because by knowing about some other module, all of a sudden you have dependency on that other module. So if my selection tool knows about the figure, and if my figure object changes, I change the code for figure, then that means there's coupling. That means that my selection tool will need to react to that change. Might have to potentially also change. So a good example of this is the Space Invaders base project. So here, if we open up the invader class, this invader class is really trivial. The invader class, its fields are all these static ints, right? Just very simple. And you might say to yourself, wow, if I had this class in a UML diagram, it has no edges to anywhere else, right? It knows about nothing else in my system. That's great. Except that if you scroll down through this method, through this class, you'll see that, in fact, it knows about missile, for example, here. Right? So this class actually does depend on missile because it has a method that takes missile as a parameter. So that's what I mean by dependency here. So if I have an invader class in my diagram, the way we represent coupling is through the depends on relationship. And it looks like yet another arrow. I know this is very exciting. More arrows. So this arrow, note that this arrow is different than other arrows we've seen before. For example, this arrow represents implements, the closed arrowhead. The open arrowhead represents depends on. So it says that invader depends on missile. Okay? So we use this to capture dependencies between classes, which in turn captures coupling. So my missile class is used within collided with, and I'm using missile.size x, missile.size y. And so if I change something, like I rename size x to be a lowercase, then all of a sudden I would need to come to this code and change this code. So this is what we mean by coupling. The fact that if you change something in one class, you'll have to reason about that change in a different place, in a different code. You'll note that down below in the handle boundary, it also depends on SI game. Right? So there's multiple dependencies for invader. So in a UML diagram, you would have these actual dependency edges. One thing to note is that dependency edge always is overridden in some sense by the other edges that we've already observed. So if I have, in my kitchen simulator, like in this diagram, I have a relationship between kitchen and recipe. It's an association. So that automatically implies that there's coupling. Right? So I don't draw another dashed, arrow between these guys. Because I already have an edge, and it's an association. It's a much stronger dependency. That's the way to think about it. Okay, so this is all I'm going to say about coupling and cohesion. Online, you can find the lecture lab on the schedule. So you can use this thing to practice coupling and cohesion on your own. Great. See you guys on Wednesday. Have a good weekend.
You're gonna laugh, both. They were actually all really close. Too high. I didn't do too well. I was like a midpoint. We did math.
And then I just infuse the walls of the blood clot. Okay, thanks.
Like in just the one task, you do this much code. Just in one task, it's like 6 or 7. That's just one credit.
So I just find,
They have one credit.
Way too long.
I did not.
Yep.
I guess it's like